Okay, same figure as in part A. Now they want us to find the volume of the solid generated when R is revolved. So when they talk about revolving R, I know that they're creating a solid whose cross sections or slices will be circles. And because there's a gap, let's see, a horizontal line y equal 1. So that's a line right here. That's the axis about which this region, R, gets rotated. I don't really care what the object looks like. All I care is that every slice is going to look like this. And I simply need to identify this area of the slice. So to find that area of the slice, I have to find the area of the entire slice as though there is no hole in the slice. So the way I do that is I come to the axis of rotation, I draw a line towards the region all the way to here. The length of that line will be the radius of an entire slice. So it will be the radius of the entire slice. It will go from here all the way to here. So the length of that green line is the y-coordinate at the top, which is 1. Subtract the y-coordinate at the bottom, which is again my formula for g of x. So this will calculate the radius of one slice. The x can be changed, so I can calculate the radius of any slice. If I then square that radius, multiplied by pi, that will give me the area of an entire circular slice. If I change x to different values, it will give me the area of different circular slices. Slices at different spots. Now what I want to do is subtract out of the middle this area where there is nothing, because that's just a hole. So that radius goes from here to here. So the y at the top is 1. The y at the bottom is defined using the formula f of x. So I can plug in different x's, get different radius at each point. I square that, multiply that by pi, subtract this now thing in big parentheses. That would be calculating the area right here, this area in here of one slice. And the area would be different for each and every different slice. And that's what x is for, because with a different x, I can be calculating a different area of a different slice. I take the area of the slice, I multiply by the thickness of the slice. That now calculates the volume of one slice. I want to calculate that volume for each and every slice. That's the purpose of the integral, is to calculate the volume of each and every slice. So here's how the problem would be graded. They give 2 points for the integrand this time. 2 points. They're looking for either this red box or this red box. And if I'm going to use G and F, I have to make sure I have written down on my paper what F is equal to and what G is equal to. Although if I did that in part A, I don't have to do it again in part B. I just rewrote it here as a reference. But if I did it in part A, I don't have to do it again. So you don't have to have both of these, just one. Either one with the correct red box would give you 2 points. It must be perfect though. You can't leave off the dx, you can't have the square in the wrong place. It's got to match exactly. They are not tolerant of close. Then they give 1 point for the correct decimal answer. Again, it must match perfectly what you see in the green box here. So, oh, also in part A you must have written. Oh, actually, they didn't give points for the limits here, so this didn't have to be written down in Part B, although it didn't really matter because we wrote it down in Part A.